Hello everyone, welcome to another video of Calculus 1. In this video, I'm going to explain the derivatives of exponential uh, and logarithmic functions. Let's see what logarithmic function is. So if you have, uh, first you have f of x equals natural log of x, or you may have based on any uh, base of log a x, and it's also a logarithmic function. And you can have functions like f of x equals e to the power x. These are exponential functions. uh, e uh, natural exponent, and then you could have uh, f of x a to the power x, or f of x b to the power x. So b could be any base. This log function of that could be log b, base b of x. So first, we previously talked about exponential functions, but since these are related to each other, I would first talk about exponential functions. D over dx e to the power x is e to the power x. I think we obtained this previously. And now from this, we can obtain derivative of logarithmic functions. For example, I can obtain uh, I can write f of x equals uh, natural log of x, and natural log of x can be, or you can write y equals natural log of x. And from that, using exponential rules, you can take e to the power y is equal to e to the power natural log of x. So this is e to the power y equals x. Now we learned implicit implicit derivatives. So by using this, I'm going to find dy over dx. So I'm going to take d over dx of both sides. So when I do this, I can use the chain rule, d over dy e to the power y times dy over dx, and d over dx x is equal to 1. Now I can use this equation, this one right here, to write e to the power y dy over dx equal 1. Now this gives me dy over dx is equal to 1 over e to the power y. So 1 over e to the power y. So e to the power y here in this case, if you look at this step right here, this step right here, you can see that e to the power y is equal to x. So I'm going to replace that, and also I can write d over dx. Y is natural log of x, which is equal to 1 over x. So that's our equation. That's our equation. And based on the same principle, we can obtain another relationship. We can see that uh, I'm going to write it here. Whenever you are given function y equals uh, natural log of f of x, right? By using the same principle that we learned earlier, what we can do is dy over dx equals d over dx natural log of f of x. Now I can take f of x as u, so let f of x equals u, or u equals f of x. By applying chain rule, I can write d over dx y equals d over du natural log of u times du over dx. From that we get d natural log of d over du natural log of u is equal to from this equation, from the equation shown in here, we can write it is 1 over u times d over dx. U is f of x. So that means d over dx, y is natural log of f of x, natural log of, natural log of f of x, which is equal to f of 1 over u, that is f of x, and this is f prime of x. So you can obtain this relation as well. These are sometimes useful when you're working with problems. And in summary, we learned this equation we already knew. That's equation 1. And then this equation we learned in this class 2. And then second, this equation is 3. So these are the 3 equations that we learned in this lesson. So we'll see in another video how we're going to use these things in problems. Thank you very much for listening and watching the video. Uh, if you need to watch, if you need to see how the problems are uh, analyzed by using these 3 equations, please join the next video.